Welcome to Daring Marina YouTube channel. Today we will be discussing about AC motor, its principle, working and other types. AC motor, basically it is a motor that converts AC current into mechanical power by using electromagnetic induction. This is known as AC motor. For AC motor there are two important parts. They are stator and rotor. Stator means it is a stationary part, rotor means rotating part. Then asynchronous motor or induction motor. This is the most common form of motor used in marine life. Basically for water pumping or overhead tank in the boiler feed pump, these kinds of motor rules mostly in the marine industry. These motors are very flexible to use and matches load demand almost for everything. In DC motor, we give one supply to stator and another to rotor through brush arrangement. But in induction motor, we give only one supply to stator. As the name suggests, it works on the principle of electromagnetic induction. So, when the stator windings are connected to AC supply, flux is produced in the air gap, and due to this, flow of current will be happening in the coil. Here what is happening is, in DC motor there will be one stator and rotor, and through brush arrangement it will work. But in the induction motor, we give supply to only stator. So, by the principle of electromagnetic induction, the stator windings connected to AC supply, flux will be produced within the air gap, so that due to the flow of current in the coil. And this flux from the stator cuts coil in the rotor, and as rotor coils are short circuited, according to the Faraday's law of electromagnetic induction, the current will start flowing through the coil of rotor. When the current flows through rotor, this coil flows. Then another flux will get generated into the rotor, and now there will be two fluxes. One flux is the current flux generated from the coil of the rotor, another due to the current will start flowing, and this due to law of electromagnetic induction, one flux gets generated, and this one is stator flux and another will be rotor flux. This rotor flux will be lagging in respect to the stator flux. Because of that, rotor will feel a torque which will make rotor rotate in the direction of rotating of the magnetic field. And due to the lag between the flux current in rotor and flux current in the stator, the rotor will never reach its rotating speed. Therefore, this induction motor are referred to as synchronous motor because they operate mostly at a speed less than that of synchronous speed, and they can never reach that excited speed. That means they can never operate at speed same as that of synchronous speed. They will be always operating at a speed less than synchronous speed. And another one is synchronous motor. Synchronous motor is, we can say, exact opposite of synchronous motor, means its speed remains constant under varying load. With varying loads also their speed remains constant. So it is used for driving continuously operating purpose with constant speed. If you want to pump water or any fluid with constant speed, then we can use synchronous motor. But when supply is given to synchronous motor, a revolving field is set up. This field tries to drag rotor with it, but it could not do so because of rotor inertia. Hence, no starting torque is required. So, thus an inherently synchronous motor is not a self-starting motor. So, we need to external help for starting. But asynchronous motors are self-starting motor. Due to the two types of flux that producing inside it, it will automatically start rotating. But synchronous motor is not self-starting motor, because means when supply is given to synchronous motor, a revolving field is set up. So these fields will try to drag the rotor with it, but could not do so because of rotor inertia. So now starting torque is produced in it. So it cannot start self. So we need a self. This is not a self-starting motor. Thank you.